Hello everyone, welcome to the equation web. Today we'll be doing some more arithmetic problems. So let's start with the questions. So today's questions will focus a lot on prime numbers, and they will also use modulus, which is related to the subject at hand. Both questions will also use basically the same rules and the same modulus, so you'll see that when we get to the second question. So today's first question is, find all primes p such that p squared plus 2 is also prime. I'll give you guys a little bit of time to solve this question for yourself. So firstly, we can try and plug in the lowest prime number that we know of. The lowest prime number that we know is 2. So let's plug that in. If we plug that in, we get the answer as 6, which is not a prime number, as 3 times 2 equals 6. So let's plug in the next prime number that we know of, which is 3. When we plug in 3, we get the answer as 11, which is a prime number, which means that 3 is one of our solutions. 3 is also related to this type of problem in another way, which we will see later on. So here's how 3 relates to this type of question. If we plug in any number greater than 3 into p squared, we will get, for example, let's say we plug in 4, we get 16. If we divide that number by 3, we will always get a remainder of 1, which means that if we plug in any number greater than 3 in this equation, we will not get a solution. You can plug in any number really big or really small, and you will get this answer if it is greater than 3. So let's plug in a number greater than 2 into p squared plus 2. We can use our original rule that it will have a remainder of 1 if it is greater than 3. And if we take that and we add 2 to 1, we just get 3, which is obviously divisible by 3, which means that it is not a prime number. And that proves our statement. This means that 3 is the only answer to our expression right here. Here's our second question. Find all primes p such that 8p squared plus 1 is also prime. This is like the question we did before, so I'll give you guys some time to do it and find your answer. So first, let's plug in the lowest prime number we know again. So let's plug in 2. If we plug in 2, we get 8 times 4 plus 1, which is 33. 33 is 3 times 11, which means that it is a composite number and not a prime number. So let's plug in 3 into this expression. We get 8 times 3 squared plus 1, which is just equal to 73. 73 is a prime number, which is kind of odd because 3 has been a solution to the last equation and this equation as well. The reason for that is the rule that we talked about earlier. If p is anything greater than 3, and then p squared is always going to have a remainder of 1 when you divide it by 3. This means that it will not be a prime number, which means 3 is the greatest solution and the only solution. So let's do the same thing that we did for our last question. Let's plug in 1 for p squared, as the old rule stated. So if we plug in 1, we get 8 times 1 plus 1. 8 times 1 is 8, plus 1 is 9. 9 is divisible by 3, which means it is not prime. This is another question that has proved the rule that we stated twice. So we just solved 2 questions, but our second question was, find all primes p such that 8p squared plus 1 is also prime. The answer to this question is that p is equal to 3 is our only solution. That was our solution to the other question as well. Thank you for watching, and make sure to like and subscribe.